Hello, great pleasure to meet you here in Bucharest. It's my first time in Bucharest, and I've been watching Romania since 15 years from the other shoulder of the Danube River as I was living in a small city in Bulgaria and never been here. And it's really great pleasure and honor to finally be here. So thank you so much. So a few words about me. The main thing about this is that I like airplanes, and I like Java Enterprise, and I like organizing conferences. So, okay, so plan of the day. A little bit rethink about the way we use the system resources on our machine. So the main takeaway is you not to learn something too much new, but to try to find a right way to uh, give a better approach to how you design your programs and your APIs. So the first thing we need to understand here is the word asynchronous. So as I copied from the Wikipedia, so I'll just read this. It's a former computer control timing protocol in which specific operation begins after receiving a signal. And it's not going the same exact rate as something else. It could go somewhere on the other side. So if we put it in simple words, we just start the task somewhere else, and we wait for the task to notify us if it's done. And then we will, just process the results. And in terms of Java, we just start a new thread, do something there, and somehow get the results. And why on earth should we ever do this? Because it can be faster. It can be much more efficient to our programs. And because that's the God speaking from above. Oh my God. Is it not correct? Should I go ahead? Okay, I guess so. Yes, it can be really fast just because it's not blocking. It's not blocking because blocking is waiting. It's doing nothing. We should not block, never. Okay, so, and to get the right understanding, there is only one class in Java. I wonder if he can hear what we hear. Anybody home? Some technical guys, may you just, switch the channels if it's possible? Okay, thank you. So to get the right understanding, we need to look at all this thing at some different perspectives. Because actually several technologies made it possible. Yes. And let's first start of the evolution of multi-threading in Java. It's very hard for me to talk because here sits the greatest master of concurrency I've ever met, or just in the world. Let's be honest, Heids Caboose, who will tell you after this session actually more think about multi-threading and how can you utilize it in the best way, but I'll try to scratch the surface. And how did we actually run threads? So we have something called runnable. We implement the run method and get some data and just use it. Or we can, extend the thread class and use it once again. But we somehow need to extract the results from running this application from the thread. And here comes the hard part. So how to get synchronized? How do threads do not interact with each other, and so on, so on. It's very hard. So parallel programming, it is hard. It's very hard. And that's why even reading this wonderful book by Brad Gotts, I read it almost every half a year, and I still cannot understand everything from it because it is hard. Yes, and after that, some evolution, so not just threads. There was in 2004 came the concurrency API with the release of Java 5, and we some kind of not had to think in such a low level about all this stuff. So we have some executors with services. We can use fixed services, how many threads should run, and so on and so on. And we can run tasks which do not return result and handle them in a more graceful way. But It was still hard, but with it came the future. Yes. And what is the future? You'll be surprised, but that's a primitive for creating multi-threaded applications. So, and it's actually not something very new. So the main concept of future was developed in 1977 by these two wonderful people, Eric Barrett and Carl Herried. And let's think how actually, what are we talking about? So we, for example, imagine we have a function which actually does some job. It returns us a magic int, let's say 10. And it's a work to be done. It's some processing time. And what does actually future? Future put this work in some kind of container. When I say container, I read it in I still hear competition from that microphone. Okay, so a container is not actually something which is inside of the specification for future and so on, but it's very handy description of actually that we put a work in something which is, that stores our work and cares for our work. Please don't do that again. Yes, and stores the work for us. And containers are everywhere right now, so I'm, very updated. So, and future, so we put this work in a container so it can be handled, so we can care for this work. And you will be surprised, but function for putting a work in a container is called promise. So you always need promise and hello. How is hello in Romanian? You hear them. Okay, that's... Now it's not working anymore. Let's wait. I should not lock, yes, but I'm not using this wonderful class I'm going to talk about. Some technical... Alin, can we do something with this? Yes, please. It's a technical pause, sorry for that. Maybe I should continue. Can you hear me at the back? No, because you're going to miss something very useful. I'm going to sit and wait. Oh, yes. Damn, I'm blocked. I've never felt this experience when I'm blocked. That's the reason for this session. I'm now feeling blocked. I'm useless. I feel it on my, Please, Heinz, do something. I'm blocked. I have to use this device, you told us. I wonder if they put this on the YouTube. Us waiting.
Do we? Test.
It's written, it's channel 13. Well, 1 more minute and I'll get without this technical stuff. I'm sorry, I don't know jokes in Romanian. We have to shift the conference for tomorrow. It's not working. Okay, be prepared. You'll come home very, very late today. Well, one more, 2 more minutes, and I'll just go ahead.
Doi. Doi, doi, doi.
Well, just like on every concert, we'll shift everything with 2 hours, and we'll be okay. Oh, yeah, baby. Okay. No. Once again. One. Should we go ahead? You can hear me from the back. You're the best. Awesome. Yeah. Okay, so what is it? No, I'm not too loud. Okay, what is the promise? So it's a function to put a work inside a container. So, and it's also not something too much new. It's actually was proposed in 1976 by these two people. And Peter Hibbert even called it eventual. You know, you feel the idea of events, you know, it's eventual. And what is actually the idea of the future? So we observe the container. Well, there's some work inside. It's happening. It's calculated this magic number. And the main idea is that this calculated number should actually never ever go outside of the container. So it should be transformed inside of a container on the very final, whatever transformations are made. So we just put it out of the container and use it. So just with a callback. So conceptually, in the future, you never get out of the value out of side of the container, because this way you are switching to synchronous again. So try to be asynchronous as possible. So what is future in Java? Future in Java is actually something very, small and from the first glance very handy. So we just take an executor and we submit a task to it. So we put this task inside of a container. And what can we do? We can ask him, is it done? Is it done? Is it done or it's not done? Yes, and then we get the value out of it. So the interface is really, really simplistic. So it's only 3 main methods that we actually usually use for futures. But there is something about these methods that these get methods are blocking. And this is not something we want. So we're breaking the law here somehow. This idea of the work should not be interrupted, should be inside of a container, should be handled like this. So we're breaking the law. So if we take a look at 2 threads running, so we submit a job and then we immediately do a get. Then the other thread starts waiting for the result, and it's actually doing nothing. And our idea is to utilize the resources as much as possible. So we want to do something useful inside of this trap. And from definition, we don't have to block. Good for us. But how can we block? We should make callbacks, as we told you. The results as they are ready, as it's baked, we should take them out of it. And callbacks are, let us see. So imagine you have a very, strange function. So process something in an asynchronous way. I've put a lot of specific Java 8 code inside, and even this. So we take the results, and if it's okay, we accept, or we on fail handle this exception. So a lot of code. And if we just want to calculate Fibonacci's numbers on a special executor, for example, made for us, should we use it just like this? Can you recognize this notations, by the way? So it's Java 8. How many of you are using Java 8? And how many of you have ever made a Lambda code on Java 8 at JVM? Try it someday. Yes, it's nice. Yes, and actually my first idea was to make a special tweet function to calculate how many times we hate Justin Bieber. But since internet can be break on conference, I've switched to something more useful like calculate Fibonacci numbers. Yes, and now, for example, if we want to make something even more awkward, you know, for example, I want to calculate prime numbers. Then after it, we want to calculate Fibonacci's number, and then we want to intersect them, and it should be done, and then print them. It should all be in a synchronous way. It starts to look pretty crazy. I'm not sure how many of you can read this, but I personally, when I see this code, I just close it and never look at it again, because the real work is actually done in these functions. So we just get primes, we get Fibonacci's, and even here at the system out print line and our system and so on, I even cheated, because the good idea is to make primes, then Fibonacci's, then intersect them, and then print them. But this slide just cannot get enough information to show everything so the people at the back can see. And it's awkward. It's really bad. In terms of Java, with its way it expresses the asynchronous stuff, even with all this small stuff that we done with the executor, it's heavy. We don't like it. But somebody else actually did this somewhere else? And of course, we think about, you know, JavaScript and Node.js. And when it actually arrived, it was so much cool, because it's non-blocking FEI, it's event-driven model, it's so cool. And everything is done with callbacks. And we say, oh my God, that's so much cool. You don't have to think about threads. Everything is single-threaded. All this underneath that happens for you. JavaScript is single-threaded itself. So it's a good means to express it. But in reality, what we have, callbacks everywhere. Yes, callback hell is something which is very much typical to use in early Node.js applications. And if you say callback to a JavaScript developer, it will start instantaneously. This is a quotation from Venkat Subramanian, and it's really like this. So in reality, we are not so much cool about this thing, but there's something called promises kind of fix that. So instead of inlining the function inside, and using callback, and do something useful in the other side of the monitor, if your monitor is wide enough, so we can make it even more beautiful, like this. So we call, we know that something will happen sometime, and we say, then do this, then do that, then do this. And we even have a graceful way to catch the exception and handle them and so on. And not only in JavaScript, but actually Guava was one of the first who actually broke the law with this small features that came in and addressed the same issue, but it was too much complicated because Java itself, Java 7 mainly, didn't have this way to express in easy way the callbacks. So what we did, so we have an executor which was decorated somehow to be, you know, nicely visible by Guava listenable future. And as we submit the task, we can register a callback, which has only two functions: is on success and on failure. So it's also very hard to read. You see a lot of code inside. It's hard to maintain, and it's very hard to debug. Believe me, I've tried it. But still, and it also provides the function of transform, but still, it was a kind of a game changer because many latent application, so we first time heard the word latent, and latent is something that will come to an end. Latent application, like for example, Cassandra database, they actually return us futures. They don't return us work. They're not blocking until they search. They returned us this Guava future. So we were able to choose, should we wait for the execution to finish, or should we, you know, chain the functions and reuse it in a synchronous way? Is it like this? Yes. No, you haven't tried it. Well, I've tried it. It did work. But Cassandra is a good story. Another way to do this is J-deferred. So I've talked to a wonderful guy called Alexandrov. He actually did this, and it was inspired exactly by jQuery. So it has almost the same syntax. So you have something, then you do something, then it's done, then it's failed, then it's in progress, etc., etc. So it's quite beautiful, and it's very much verbose, I would say. So you have a lot of function. It's cool. Thank you. Okay, so let's now put it all together and try to achieve this asynchronicity in Java 8. In Java 8, it's done by only one single class. And you know what it's completable future. Yes, and it's beautiful. Nobody can read it, but it's beautiful. So the fun and the good thing about it is it's core library since Java 8. So you already have it from out of the box. If you download JDK 8, so you already have it in the box. And how did they do this? They did it in a very good way. So they first extended the future interface, and they've added some more interface functions, which are realized in completion stage interface. And as you probably know, Java allows you to make a multiple inheritance of interfaces. So that's where actually all the magic is done. So we have future and we have completable future with lots of new wonderful function inside. So we can use it as future, or we can add some really good stuff like, composing elements, function resolutions, transformations inside the chain of the flow, let us say, of the calculations that we have to make. And it's very much good for asynchronous operations. But let's take a look at small foundations that actually made it happen, because I told them you need several technology to make it useful. So the first, of course, are the lambda and the method references. So you don't have now to write this awkward code when you have to make anonymous classes and so on. So you just put in some lambdas or some method references, and it's pure, and it's readable, and you can just use it in asynchronous way. Another foundation for this is, of course, the for join algorithm and the for join pool, which is available since now Java 7. It's a ideal helper for async programs. I'm not going to talk about it too much because Heinz will do just another session. Please join his session. He will tell you more useful things. Huh? Well, it depends. Okay, so but the idea is that it really cares for cache, for corruption, and it's very much optimized for creations of tasks. I would say it like this. So you can make many tasks, and it will handle it correctly. And the idea is, which is used, so for example, if you have several threads and many tasks in it, so the for join algorithm function called work stealing. So if you have some work to be done in one thread, it would try to keep it as much possible in one thread, and if it's full, it would steal the work for other thread, because as you probably know, if you do some work in one thread, so you have all the processor caches inside, and it really fastens your performance than just putting it out to another thread. So for join algorithm is good for that. So, and if we are back to the computable future, so we have a very easy way to create them. So first of all, it's a class. It's only one class that represents full API. That's so beautiful. And you create new classes as well. But there's a better way to do this. So we can make a function and supply something as a completable future. Or run something which does not actually consume any results or produce any results asynchronously. Asynchronously, which is meaning that it's running on a different thread. So you can even specify an executor for that, which is actually giving you superpowers. Because unlike streaming API, where you use for join pool, by default you can now switch executors. Here you can do this. And it's wonderful. So if we run async, we still use for join common pool by default, but you can supply other executors. So, and we can stop them. So we can complete the futures with the value we want, and we can complete them exceptionally to tell the program that, okay, we're done. So you can use this value in the future computations. And the idea is that we can complete them only once. And Still, that does not exclude blocking, so you have to handle about this, but we'll come later to this question. But then you stop everything. So you just make then accept, then run, and we end the chain. So let's take a look of the code of the same asynchronous stuff that we have done.
And let's see how it works.
So for example,
we have primes.
And we have a function. I'll
Make it a little bit bigger.
make it a little bit bigger.
So people from the end can see this.
Thank you.
Okay, so
completable future. Supply sync. Then we make a method reference. So in our initial class,
we have a method.
get prime numbers. Okay, we calculate that, and after they are calculated, we call then accept method, and we print them out. So we also use a method reference. So it's like system out, then out, and print line. Let us make it work. Oops. What is that? Let us make it work. Give me a second. So if we run, oh my God, no. I wanted to ask you and I spoiled it. Why? No, it's okay. It's wonderful. Okay, so that's the idea. You see, we have only hello Bucharest, and we never saw actually results of getting primes. What has happened? And this wonderful guy told us. You see this async stuff, it runs on a different thread. You know, our program actually stops before even the other thread says stop working. So we just have hello Bucharest and so on. And if we made something that makes us, you know, for example, wait a little bit. So moment, it's like system, then then read. For example, it will wait for our response for some time and run the same thing again. It will first print us hello Bucharest, then calculate the primes and print them. So you see, have you seen something about threads, about all this wonderful stuff? No, you just made a multi-threaded application with even using the word thread. It's crazily good. I love it. And you see, you utilize two threads. One of them is hello Bucharest, for example. And if we, as you told the guy, if we just print thread from here, and just give me a second. I'm not good at typing. Current thread and print its name. And if we put this thing in the code again, so we will see that all this function is actually executed in FarJoy common pull worker without even specifying all these things. So we're making a multi-threaded application in an asynchronous way with threads. Not even we're using the word thread. So it's kind of amazing, I believe. So when I first time saw this, I would say, oh my God, streams, lambdas, that's so cool, but completable futures are actually something that reuses the resources in a much better way. So remember this thing, as they say, that we have to transform the values inside of our containers without getting them back. And for this, we have this wonderful function, then apply. So if we get these methods, and we can, as you told me, get the primes, we can also get another function, for example, which will calculate the average for us, and just chain it here in the middle. Then apply. And, for example, we want to take the average of all this list. I hope it will work. Yeah, we have the function average. Initial. So we, as you see, we do not supply everything. We just get the method name, and it's okay. So we first calculate them. Then we calculate the average.
And I hold my processor. Oh, I see. It's calculated even in two workers because, oh, I just copied it. I want to say why. I had no answer for that. I believe control, what was that? ID is not always good. But anyway, so you start this function and you see it first calculates you in one thread the prime numbers, and then as they are ready, we calculate the average of them. So it's done smoothly. We can chain it. It looks really cool. We cannot do this inside just writing a program. So let's dive a little bit deeper. As we told you, we can transform it. But imagine we have a situation where the function itself returns us a future. So but since the future is a class, to avoid making completable future of a completable future of a completable future and so on, we can use just method then compose. It will unwrap us the future itself, wait for it to be done, and it works just like flat map for us. So if we take a look at this file, for example, read file asynchronously, which returns us a future, a completable future, and we want to chain it somehow, we can supply async this thing and make a then compose method. So since it returns us the future, it will unwrap the future, get this work done, and then process the content somehow and then print it. So it looks pretty awesome. You see, it's smart. The API is very smart, although it's hardly readable. We can do even more. For example, we can combine several steps and reduce them to one next step, and that's done with the then combine function. And it can be done both synchronously and asynchronously. Here you have the possibility to control whether you want to make it on the same thread. For example, if you know that your resources are residing on this thread and moving the resources itself is a hard operation, so you can make it on this same thread, or if you don't care, you just push it async and let the for join do this work for you. And then you just combine. For example, remember this situation if you have two futures. So one of them is, for example, getting primes, other Fibonacci's. Then to make something with them, you first have to get both of them. Get the first future and get the Fibonacci's future. And here, and then intersect. And with this function called then combine, you can do it even better. But we will see it as an example because we're running out of time. We will see it as an example a little bit later. So you also have the possibility to understand if we can accept both futures to be done or run something after both futures are ready. So we have methods for that. Or we can just wait for one first available result. And it's kind of a cool, but there is something you should try to think about. But if we have the first result ready, what will happen to the next result actually? And actually the next result, it's not gonna be released as a resource, I would say. So it's gonna hang out somewhere because other completable futures can be dependent on this completable future. So getting first result is, I've never used it in production, although people say a good example for that will be, for example, it's mentioned in many conferences, getting the first, if you search for a DNS entry and you ask many servers to search for a DNS and you only need one result, not to wait for all servers to respond. The first result that you get is enough for you, and you spread these results, but those results that will come after you, they will not be released as a resources, as I get from this API. So it will, you have to handle it with care, I would say it like this. Or you have a special number, like called number of dependents. So I don't like this function. I've never used it in production, and I don't think it's a good idea to use it. Sorry about that. So the same thing is you can transform, not transform, but yes, exactly, transform the results on some of the futures that actually come first, like, you know, try apply to either. Or you can wait all of the futures to complete, or any of futures to complete, with these calls. But have in mind, take a look of what are the return types. So if you use all of futures, it will return you void because it cannot determine what actually will return the future or the list of the futures you say all of. With any of, it's like more to determine. That's why it's called just object. So you cannot say, for example, I need future from string, from integer, from some kind of object, and any of is more useful, let us say it like this. But still, I personally didn't have any chance to use this in production, so it's kind of we don't need this too much, but you have this API, but handle with care because the return types are completely different. So, exceptions that you saw all in our stuff written there, we, in this asynchronous stuff, we actually made a possibility to handle the exception in a graceful way, so we pass the exception along the queue. And it's done automatically for us in completable futures. So, first of all, you can exceptionally stop the execution, but you can also gracefully handle the exception as it happens. So, and all the exceptions are actually not from the step behind, but passed from the chain that you use. So if we use handle, for example, we can see that we have a lambda expression with two parameters, which is value and the exception. And we can make it kind of a graceful way to escape. So if the value is okay, we just process it somehow. If no, we can log the warning, like Houston, we have problem here. Yeah, so it's graceful, I would say. And if we take a look at this code as it's written for reading a file and processing its content, so we supply it asynchronously. It reads somewhere in the threads this file. As it's read, we can process this completable future with the process content. We can print it, but if something happens, we say that if there is an exceptional completion, so it will print out the stuck trace. So we will not hang in the middle and don't know what to do. So it's not exactly debuggable, but still we have the information about this. So let's go. As you see, the API is quite big, unlike the future. So it's really big, and the common pattern is actually a function. Then you have a sync, then you have parameter, and you have an executor for this. So in common, one class has almost more than 60 methods inside. So learning them is crazy. That's why people don't want even to start with completable futures, because the names are a little bit fuzzy, and there are lots of methods. People just get scary out of this. But what is it about? Completable future is very much for asynchronous processing. If you can organize your work in tasks or events, it's like do this and that, do this or that. On in failure, you can recover, and you can organize your work in flows, events, and tasks. So completable future is exactly for that. So we have pieces of independent work which has to be done somehow. Completable future is exactly for you. I would say it like this. Because you have exception handling, you have flows, and you reuse your resources, since you are using asynchronous execution and you run it on different threads without even noticing that, which makes it really good. But we have some bad heredity. Can you guess what is the bad heredity? Anyone? Okay. Of course, it's the get method. Get method, since it's inside the future, we should implement get method somehow. Yes, and its get method is blocking, and it's bad. So you can get values. They actually added another method called join method. We'll see how to use it. But getting is blocking. So if you see a get method inside your chain of completable futures, you are breaking the law, let us say. You not have to be punished, but you're breaking the law. And you have to think that, okay, all this synchronous stuff, which is so beautiful I have made, is broken only just by one method. So take care of it. And the other thing they've done it is also called join. Join is unlike the get method. It throws an unchecked exception. So, and this is also kind of a game changer for us. And let us see what we can do out of the join. It's actually, I was impressed when I first saw this way. Imagine we have some random sleep task, which actually sleeps just 1 second and calculates one random random number. In our project, which we used, this job was actually sending an email. Its terminal job, send an email. It can last for some time. And we want to somehow optimize this work. And what can we do? If we reuse the other thing in Java 8, which is very useful, it's called parallel stream. So if we know that these tasks can be executed simultaneously, like, sending an email, it does not depend on everything. It just send an email. You can send them simultaneously on all threads you have. We can use parallel. Oops, sorry about that. Yes, you can see. We say just parallel stream. Do this for us. It's terminal. But there is one thing we can do even more optimal. We can say, okay, let us put this work in a completable future with a special executor, which we specify, fixed executor pool. And just, in a stream, make them work. And then we, as they got back in the stream, we just join this result together. So we are reusing this join function. And you will be surprised if we run this code. Let us take a look how it will perform. Let's have a look. So this is a parallel stream processing. So you see we are reusing the fork join pool too much. And for a simultaneous work of 10 processes, each of one takes 1 second. To execute this, we need 2 seconds, which is not bad, but still, let us see how completable future performed. You see, it only takes us 10 milliseconds to spread this work in completable futures and join it back. So it's twice as fast. Just have this in mind. Why should you have this in mind? Unlike the parallel streaming itself, we are tied to fork join pool. We cannot change executors with streams, which is, I think, a good idea for a proposal to make streams with executors. It will break everything, but still. Yes. And fork join pool can be, what I say, polluted. As JVM runs, it has this common pool, which starts for all applications, and streams, different servers, servlets, and so on. They reuse this fork join pool as much as possible. And it can be polluted, let us say it like this. And here, with the completable future, we can specify our personal thread pool, which is only for us, only for our application, and it performs really much better. So have this in mind. So, and you see, completable futures and stream live together peacefully. Well, at least they're not so much debuggable, but still they live peacefully. I would say it like this. So, and we're moving forward. And there's another way to get the value. Of course, is the truth value. Never use that. I'm just saying it. But let us have in mind. So imagine you have a RESTful service which does some computations for us, like calculates Fibonacci's, then price, then makes an interception. And then we want to return these results to our customers. And how we do this, it's not good. So we have a lot of asynchronous stuff here, like Fibonacci's intersection, so on. But we have get. That's bad. We have get. We should avoid it. It's not good. So if you take a look of the actually how it's done in threads. So we put one thread for primes, one thread for Fibonacci's, but still the main thread here is doing nothing. It's waiting. It's blocked. It's not good. We don't want it. But with the latest Java E7, we have received something very, very uniquely beautiful. It's called async response. Async response. So if we get this thing done, so we have async response, we get all of the futures, and then we apply async response resume. So everything is calculated asynchronously. So we calculated primes, we calculate Fibonacci's, and only after they are all calculated, they are actually asynchronously returned to our customer, which makes it really beautiful. So if I run the server, you will be surprised, but I just use a regular Tommy here. Give me a second. I run a service. Here, you will not see, oh no, hey, what's wrong? No. Oh, I should stop this thing, I guess. I don't like it. That's strange. Okay, never mind. So if we do this, once again, we are doing an asynchronous response. So have in mind, get is evil. If you get in your code, have in mind you're breaking the law. So stay fully asynchronous, and Java actually gives you a good way to do this. And as I told you, this idea of these services, we have used it in our code very much. So we have created a microservice, because everybody creates microservices right now, which actually does some search on a very heavy database. And we know this search takes us time. It's latent operation. So it will take us, a second or 4 to do this. And we want not just wait for it to happen. We say calculate it and return us as a completable future. And we will think how to handle it in a better way. Should we use get method like this awesomely bad stuff? Or should we use asynchronous stuff all over the chain, which makes us wonderful, gave us the possibility to use our microservice in absolutely asynchronous way. So we were, reusing the resources as much as possible. So it's a kind of a production code. So, but you know that Java 8 arrives in July 2017 maybe, and there are JAPs that actually extend the completable future, and they are very good done for actually mainly for timeouts. And there was some interesting way you can do this with JAPs 276. So for example, you can supply async something which is latent, and you can make a complete, and it will be used a kind of a default method, and you can break the law, break again the law, breaking the law, and use the get method. And this get method will be not blocking, since it will use the default value first, and then if the value is calculated, he will take this thing. I personally don't like it, because this you have a very non-determinal response. I don't like it, but still it's inside. Yes, and for another thing is you can use a completed future method, so it's very good for testing. So if you have something that is completable future, but you don't want to make calculations out of it, make a dummy function, you can make a completed future method and use it in your test, for example. So it's kind of good. But the main accent is done on timeout methods. So if you have here, for example, this is an example taken from one of the blocks. I have to say this. So, for example, we search for prices, but if the price is not good, we should search not more than for 1 minute. So it's actually very commonly used situations in all these websites that search the prices, since it has to be responsive, not just waiting for several minutes to find the best offer. But here you can specify timeouts, and it's done with
time-scheduled executor, I guess, underneath. And if the timeout becomes, we receive a timeout exception here. So when complete method is actually reacting, should we have calculated amount or should we have an error? So that's the way you should do this. Another option is, yes, as I say, amount or error. Another option is will be complete on timeout with a default value. So for example, you cannot complete this in several seconds. You just return the default value, which is actually not a good idea, but still, it's done. Okay, and some more words about reactive stuff. So, as you say, reactive is a new cloud in our ages. So, if you program reactively, everything was written by there. So, but until serverless came out. Now, serverless is the word. If you code serverless, you are the Java Geek Party's hero. But let's be honest, it's not much view, it's just an observable pattern. So as the keyword is asynchronous, and as you probably saw from this talk, Java 8 supports this pattern really nice. So if we go to this wonderful site, you know, everything has a manifesto right now, and Reactive has also its manifesto. And you've probably seen this picture many times, but with this completable future, we can make our application fit directly to this reactive pattern. So it's responsive, it's elastic, it can scale very good because we're using this multi-threaded start underneath. It can be elastic, it can be resilient, so we can handle the exceptions gratefully. It's responsive because we can control how do we actually respond. The client should not wait a lot to get the response, so it's very much cool. And it's message driven. It's not exactly message driven what I was thinking about, because messages are kind of hidden inside the chaining, because message is generated for you when some function ends and the result has to be passed for the next function. So it's message driven, but it's underneath there. So reactive is good for this thing. And in reality, for example, I have made some kind of a service just for me, which is, I didn't put the agenda, but I've measured how many response per second daily average I have on the same function, which is done synchronously and asynchronously. So the blue line is the asynchronous response. We utilize the sources better. We have more responses. And the line below is the line we use the synchronous response. So we have more waiting there. So it's a real project, and we really have about 3-4% on current task. I won't say for everything, but for current task we had some acceleration, which is good, which is actually really nice for us. So it looks really nice, and it fits well the reactive patterns, and it comes out of the box. So once again, my idea is, if you have something which is latent, for example, you're searching something very vast, and you can give your customers the opportunity to reuse their resources the best they can if you return a completable future. They will decide, should they do a direct get function if they want everything synchronously, or they can chain all of their functionality and reuse it asynchronously. So here you provide choice to your customers, which is really nice. So if you're writing an API, he's faster than us. Yes, if you provide an API, think about it. If your operations are latent, you can make completable future and give your customers even more better results, not better results, better way to reuse your code. So, but handle with care. And thank you so much. I guess the questions you can find me somewhere around. I'm recognizable. And mulțumesc, I'm not sorry, mulțumesc. Thank you for your attention. Thank you.